On today's video, we're going to revisit the sparkling green ABIT VP6 Year 2000 Dream Machine. We're going to repair the power supply and a graphics card. So the main reason why it's on the bench today is because when I used it the last time, something inside popped. The machine didn't die, but I obviously turned it off immediately. I had a look inside, but I couldn't find anything that looked like it had popped. So whatever blew up is hidden from plain sight. And as you can see, I have placed my bets on the power supply. I had a look inside and I ordered a new set of caps, but I actually couldn't see anything that had exploded. Well, I took the board out and I found a bad cap. But if we zoom in here, you can see that it doesn't really look blown. It's just bulging. So at this point I'm not sure, but one possibility here is that one of the caps has blown the rubber gasket underneath. So we won't know until we have removed all the caps. This power supply also has a bunch of these green caps that have caused me trouble in previous projects. So the power supply definitely needs attention, whether we will find a blown cap inside here or not. Well, I guess we'll start with a bulging cap. By the way, I have already removed several caps on this board, because it's so crammed, it was impossible to read the values. And I obviously had to order the caps before I could make this video. I left the desoldering gun for about 15 seconds on this pad, but pretty much nothing happened. Okay, so that cap definitely is going to need some extra heat. I was pretty sure this was a single layer board, but I'm not so sure anymore. Yeah, that did the trick. But I noticed something fishy here. Yeah, check out this lead here. It hasn't been soldered to the board, and it goes to this resistor here. So this resistor is only soldered to one side. So now I wonder if that resistor made this cap go bad. Well, there is something underneath this cap, but I couldn't tell if that's electrolytes or something else. And this is a Genpo CELE. I think we had trouble with one of these in another project, but I'm not 100% sure. Well, I guess we should solder this resistor before I forget. By the way, I took a few days off this month to take care of some stuff I have neglected in the studio. And one of those things was to bolt my flimsy bench to the wall. So hopefully there will be a lot less camera shake from now on. Although technically it wasn't camera shake, it was actually the bench shaking. Yeah, so we've had some trouble with these guys before. So we have actually revived a few boards just by replacing these. Well, I'm having some trouble with this small cap here too. So the pad is connected to this thick red wire, and that wire seems to be acting as a heat sink because the solder isn't melting. Oh, finally. That took probably about 25 seconds. Well, I'm not going to touch that wire for a few minutes. These big caps rarely go bad, but it feels kind of silly to leave a few caps in when recapping a power supply, so I just go ahead and replace all the caps. We also have a couple of caps on this little board here, and one of them is actually bulging slightly. So these are dead or about to die. Same brand as the beefy caps, so maybe it's wise to replace those big caps. I actually found an identical power supply in the case for the BP6 project, and on that power supply, either this cap or this one here that I have removed had blown so badly there was stuff everywhere inside the power supply. But I ended up scrapping that power supply because it was so smelly and I couldn't get the smell off it. I washed the board several times, but I just couldn't get the smell off, so I had to toss it. Now, these power supplies are not rare or expensive, so it's not a big deal. But the thing is, if I buy another power supply, it's probably just going to need a recap too in a few years. So I might as well just take care of the stuff I have. and I found a replacement power supply for the one I tossed, and I paid less for it than a set of caps. But that power supply, of course, is going to need a recap very soon, if not right away. And we've got more of those Genpo caps. Now, this was pretty silly. This guy here was installed here with one leg stuck into the same through hole as this wire, and the other leg stuck into the same through hole as this resistor here. But it is marked in the silk screen, so it's not an afterthought. This was designed deliberately like this. And we have our first cap with corroded legs, and it's the same brand as the beefy caps. And the last cap to remove is on this tiny board here. So this power supply was actually easier to recap than I thought, because it was so crammed. I figured it would be a pain, but it was actually pretty easy to get all those caps off. Well, nothing much interesting happened while I was installing the caps, so I skipped ahead here. Well, I did make one mistake when ordering the caps, so one of the caps down here was too wide to fit. But luckily I had a spare in my box of leftover caps, so that was an easy fix. Well, I'm a bit surprised here. We did find several bad caps, but nothing looked like it had clearly popped. And the sound I heard was very typical of a blown up cap, so not perfectly conclusive here. But I'm glad that popping sound revealed a failing power supply, so I was able to fix it before something worse happened. Okay, power supply reassembled and installed in the VP6. Let's turn the machine on and see if it still works. The fan spun up. Before we continue, I'd like to thank the sponsor of this video, PCBWay. Aside from making excellent PCBs, as we have seen in many of my videos, they also do CNC machining, sheet metal fabrication, 3D printing and injection molding. Perfect for prototyping and vintage computer restorations and mods, just like this one. This is just a few projects that we have built on this channel, and there are many more to come. Thank you PCBWay for supporting this channel. And it's posting. It's counting up the RAM. So the power supply was still working when I heard that bang. So I actually turned the machine off. So I guess this is more of a test to see if I made any mistakes when recapping the power supply. And Windows boots. Okay, this is actually quite interesting, because I have the faulty Ti4200 installed in the machine. Okay, here comes the issue. So for a moment I thought it had fixed itself. So first let me change that refresh rate so it doesn't flicker on camera. Oh, it is at 60 already. So why does it flicker? Okay, that's not important at the moment, so just ignore it. Actually, I had to move in really close to the display to show you the next issue we're going to tackle in this video. I'll fix the flickering later, that's a camera issue. So the image isn't actually flickering. But if you take a closer look here, you can see these lines here. They are of course not supposed to be there. They were a lot more clearly visible when we run Windows 2000 and Windows ME. But apparently in Windows XP they are significantly thinner. But still an issue, and it needs to be fixed. Okay, that's interesting. So when I changed the resolution to 800 by 600, the entire system actually crashed. And here you can see some more of that issue. So it is introducing some extra dots in posts and some lines in windows. And you can also see those lines in the splash screen here. Oh, stupid plant in the way. And got some more lines here. And the system actually crashed again after the reboot. So let's see if we can fix this issue. And here's the issue we're having. This is a Gainward Ti4200, real classic. I specifically sourced this card for the project because it is the most likely card to have been installed in my machine before it died back in the early 2000s. We have previously replaced all the caps on this board, and in doing so we also did a polymod, but unfortunately it didn't help. And the next thing I want to try out is to rewrite the BIOS code on this card. I'll start by removing the cooler to get better access to that chip. I'll clean this up so I don't make a mess. There are some absolutely tiny components very close to the BIOS chip. So I'm going to tape them down. And hopefully they won't come off while we mess around with the BIOS chip. Now let's add some flux to all the pins. I have noticed when working on relatively small chips like this that regular solder has roughly the same effects as chip quick. So I'm going to add a thick layer of regular solder on all the pins because it's much easier to clean up than chip quick. And this will help the solder to stay molten for a bit longer than if we just use the rework station right away. Okay, I'm gonna go for 400C and airflow set to 100 and melt all that solder. So we know from the recap that this board has a pretty thick ground plane inside. So I'm not going to be too quick here. Let's poke that chip gently and see if it's loose. And it's not. So let's heat some more. I'm having some trouble to fit the nozzle underneath the camera. So I have to hold the card at an angle. Let's poke it again. Nope. Still stuck. Well, in hindsight, I should have used a preheater. It would have been worth the hassle setting it up. Okay, this is not working. And I don't want to add more heat to the card. So apparently this chip is large enough to be worth adding chip quick. And I guess I'll just have to spend the time cleaning this stuff off later. Let's add some more flux too. Try again. Okay, let's poke that chip. Nope, still stuck. Oh, the chip quick is still not molten in this corner here. So that's probably where the chip is connected to ground. Let's give it some extra heat here. Yeah, definitely should have used the preheater. No, this is not working. I don't want to heat that card more. Wow, what a stubborn chip. Okay, the board has reached 130 underneath and 100 on this side of the board. So let's try again. I would try with a larger nozzle, but unfortunately this nozzle is stuck, so I can't remove the damn thing. Okay, now the chip finally moves. Oh, that was a really stubborn BIOS chip. While the board cools down, I'll clean up this mess. And I guess this is the drawback of chip quick. I spent more time cleaning this stuff up than removing the chip. It's a great tool, but I try to avoid it unless it's necessary. And since we ended up using the preheater anyways, we could have skipped it. And the chip too needs to be cleaned, of course. In fact, we need to get the legs of this chip perfectly cleaned, because we are going to read the content and reprogram it. I'll use some flux and good old wick. Well, lesson learned. Graphics cards, this vintage, needs a preheater. Well, that took way too long, as always. But now the chip is perfectly clean and basically as good as new. The reason for being so thorough with the cleaning is because some leftover solder could easily damage the socket. These cards are a bit funny. They have several sets of pads for different options, but the manufacturer, Gainward in this case, just left all the pads in. So underneath the caps here it's an absolute mess of different sets of pads and silkscreen markings. Well, I guess the good thing is that you have several options when you recap one of these boards. Unfortunately, this card has not been designed to take a socket. So this component here sits too close. So the socket sits several millimeters off the pads. To fix this, I'm going to grab the Dremel and shave this corner off. Now let's see if this solves the issue. Yeah, it totally does. So that was an easy fix. But these sockets are not made for hand soldering, so I'm gonna have to remove this center piece here to get access to all the pads from the inside. I'll snip all 4 corners off inside, and that should free up that piece. Like so. I'm gonna use my flux pen for this, so I don't have to clean as much later. Now I can solder the sockets. I aligned the socket off camera, added some more flux with a flux pen, and I switched to my smallest curved tip. So now we can solder all the pins. Well, this tip doesn't have much thermal mass, so this is actually not working. The card is sucking up too much heat for this tiny tip. So unfortunately I'm gonna have to create a mess with flux inside the socket here. And very carefully drag solder all the pins with my large tip. So this also means I'm gonna have to rewash this card. Well, I'm definitely getting some bridges here, but they are easy to remove. Okay, and here's the finished result. And again, it took a lot longer to clean the damn thing than to solder it. But I think we have a working socket here now, so we're all good. If you watched my video last week, you know I had some trouble with my TL866. So I replaced the socket, but I had some trouble with it. And that turned out to be some mild corrosion, either on the chip legs or in my brand new socket from AliExpress. So I promised you a follow-up, and it's only been a week, but I have used it a couple of times and it has been working perfectly. However, I made a mistake when ordering the new socket. As you can see, this socket is much wider in the center here, so I can't use it for small chips. That was a silly mistake, but I wasn't paying attention and just didn't notice when I ordered the socket. So that means I have another socket on the way in the mail, and we're gonna replace it again. Hopefully with a little less drama next time. One possible reason why the original socket died is because I used this adapter here, but it originally had some really thick pin headers, and we're going to use this adapter today. So I replaced the pin headers for these much thinner machine pin headers. Now that was actually easier said than done, because the pins, they are underneath the socket. So that was an absolute pain to replace those pin headers. Now let's find out if it was worth all the hassle and use it for our GeForce Ti4200 BIOS chip. Okay, we're in XG Pro here. So the chip we have is a PM39LV 512R, and it's a PLCC32. So let's grab it and read the content of that chip. And we're getting an ID error. That's a bit strange. Okay, I checked and we did pick the correct chip. So let's try again. No, crap, this isn't working. Okay, I'll try with some DeoxIT in the socket, since that fixed the issue the last time. But we didn't get an ID error, so that's a bit worrisome. And by socket, I mean the ZIF socket. Let's try again. No, it's not working. Crap. In that case, I'll pull the BIOS chip from the socket and add DeoxIT on all the pins in the PLCC socket. Okay, let's try that again. No, still an ID error. So what is causing this? We've got the correct chip and the correct adapter, and the TL866 was tested just a few days ago. In that case, let's uncheck the check ID and try again. So this ignores the chip identification. Okay, and now it read the contents. So here's our gain ward, Ti4200 BIOS, So the first thing I want to do is to compare the content of the chip with the code we read. I'll explain why in a minute. So I'm going to hit verify, and it's successful. So the code on the chip corresponds with what the TL866 read. Now here's the thing. The viewer left a comment that he had fixed his BIOS. Don't remember if it was a graphics card or something else, but he fixed it by just reading the content and then writing it back on the chip. Sounds kind of unlikely, but I think it's worth trying. It only takes a minute, so why not? Oh, programming failed. Huh. So is this chip bad? Oh, what's going on here? I'll pull the chip out and reapply DeoxIT on all the pins. Okay, PLCC socket, freshly cleaned. Let's try to program again. No, programming failed. Okay, so I think we may have a bad chip. Let me see if I can find a spare chip. Well, luckily I have a spare chip for the IBM M51 projects. So let's snatch it and I'll order a new chip. So this guy here is a 49LF004B. And it's a PLCC32, of course. So let's open up that file we just read from the Ti4200 and program it to this chip instead. Oh, that was successful. Yeah, so that was definitely a bad chip we had on that card. Okay, I did not expect this. My guess was bit rot, but we actually have a bad chip. Now the question is, of course, did it successfully read the content of the chip? I guess we need to find out. Okay, cooler reinstalled and a snatched BIOS chip in the socket. I added some DeoxIT in this socket too. Here goes. Oh no, we've got a black screen. So unfortunately that didn't work. We didn't get all the content of the old EEPROM. Oh crap. I'm gonna have to try something else. Well, this is not a rare card. So there's a pretty good chance someone watching this actually owns one of these. And after having seen what happened in this video, they probably want to make a backup of their BIOS anyways. And if they do, please send it my way. And we'll try again with this card. Well, while we wait for someone to help us out with the BIOS dump, we need to install something else. But the problem is, most of my graphics cards, they are more or less all messed up and need some kind of repair. So our next contender here is a LeadTech WinFast A250 Ultra. It's a Ti4600. And the caps are bulging, so if I keep using this card, I will probably fry a chip. So let's not. Let's instead fix it. Well, I tried to remove one of the caps, but that didn't go too well. This board is even more stubborn than the 4200. So let's remove that heatsink. And I think it's held down with these two tabs here at the back. Okay, so this is quite a contraption. So I think we need to remove the heatsink at the back here first. It seems to be cooling down some of the RAM chips. Thermal paste is pretty dried up. So good thing we checked, because we need to replace it. Then we need to push down these tabs again through the PCB. And this chip here has a thermal pad. So I'm gonna have to be careful not to damage it. Actually, now that I think of it, I think I have a replacement. But I'll be careful until I have checked. So let's start by removing what's left of the thermal pastes. Well, I guess this is kind of the big brother of the Ti4200. This was one of the last GeForce 4 cards. I think there were two more in the GeForce 4 series. The 4800 SE, which is slower than this card. Then the Ti4800, which is about the same performance as this card here. So it's more expensive, but kind of pointless. So this is the card to own if you want the best performance of the GeForce 4 card. Okay, let's try to remove the heatsink next. It's stuck in something. I think it's this peg here. Oh, it went back into the PCB. Locked. Okay, I pushed it down again. Now the heatsink came off. That's a really sturdy heatsink. So let's see how bad... this thermal paste actually isn't too bad. It is kind of soft. Definitely seen worse than this. We are of course going to replace it. While the board heats up, let's check and see what's going on here. So there's some kind of foam that hasn't aged well. So it has turned into crap. And someone has tried to remove this fan and strip the screw. So that could be a problem. But the other screws look good. So let's see if we can remove them. Yeah, they're coming off quite easily. So how about this stripped screw? I'm going to apply a lot of pressure and just hope for the best. Yes, it's coming off. Okay, let's see what's going on here. Oh, I think that's the protective plastic from the factory. So this graphics card has not been peeled yet. It has dried up though, so it is falling into pieces. Let's see if we can remove it in one go. No, we can't. It's so dry, it's just falling apart. So I'll remove it off camera. Okay, board has reached 104C. Let's see how this goes. No, that solder actually didn't come off the pad. And neither in this pad. Wow. Now I have cranked up the heat to 140 underneath and 110 on top of the board. Let's see if this works. I think I've only had one board on this preheater before that required this much heat. Wow, that solder still didn't come out. Well, now we know why these cards were so expensive. Most of that money probably went into buying copper for that crown plane. No, this is crazy. I'm not getting the solder out. Even with the board at 112C. This is nuts. I'm gonna have to crank up the desoldering gun. Yeah, I'm having trouble reflowing those pins. Even with this much heat. This is crazy. Okay, let's try again with the desoldering gun set to 420. The cap legs are so tight in those through holes. I'm trying to feel if it's loose, but I really can't. No, that didn't work. This is insane. And same thing with this through hole. Wow. Well, I don't want to crank up the heat more than this on the desoldering gun. So let's change method. So I'll use the Rework station to heat up that solder. Then I'm going to pull that cap off the board. Okay, and I actually took the solder out with it. But I don't think that's going to matter because I think I ordered surface mount caps for this card. So I'm going to use this method and ignore if there's some solder left in one of the pads. Wow, that was quite an interesting experience. I have never worked on a card requiring this much heat. So the whole PCB basically acts as a large heatsink. Every cap took somewhere between 30 and 40 seconds to remove. That is pretty crazy. I don't think I've ever spent more than 10 seconds removing a cap in any other projects. And despite all that heat, the solder barely melted. It looks more like it just got soft enough to let go of the PCB. That's pretty insane. It's pretty hilarious that I tried to remove one of the caps without the preheater. Now let's see how easy it is to replace those caps. Well, the solder is melting. That's a good start. Yes, this is actually going pretty well. So installing SMD caps on this board actually wasn't more difficult than on any other board. And I'm running the preheater at 140 underneath and about 100 on top of the board. So 40 degrees difference also clearly indicates that it has a really thick piece of copper inside. Okay, I'll skip that here because this was pretty uneventful. Getting those caps back on the board was super easy. Well, obviously with the card on the preheater. And of course I went with the full poly mod. This card definitely deserves it. But the old foam pad turned out to be really difficult to remove from the fan grill. I tried with IPA and acetone, but it doesn't dissolve it. So I'm just gonna have to patiently scrape this stuff off. But this piece isn't really needed, so I guess we could skip it too. Unless you're going to install a new foam pad. And I'm definitely not. But I'll clean this mess up as best I can and put it back on the cooler. I found a new thermal pad in my stash, but I'm not going to replace it quite yet, because after I have finished this video I'm going to wash this board and I'll replace it after the wash. I applied some fresh thermal paste on the card and we installed the cooler. Here goes. Oh wow, those are really noisy fans. We've got a splash screen for the Ti4600. I'm gonna put a drop of oil on the coolers in that graphics card after the wash. And if that doesn't help, we'll make a mod and install 2 Noctua fans. Oh no, something is wrong with this card too. Quite similar to the issue we had with the Ti4200. Oh, this sucks. This project is cursed. So is this a BIOS issue too? Oh crap. And Windows XP hanged. Let's reset. It looks normal when it posts. Oh, actually it doesn't. So the Energy Star logo is messed up. It's hard to see on camera, but it has some white stripes. So let's boot up in safe mode. Well, that's odd. I'm getting perfectly normal graphics here. Oh, this is a bit strange. I'm getting perfectly normal graphics when the machine runs in safe mode. So what do we make of this? Let's jump into the device manager and remove those drivers. It automatically installed the Ti4600. I also noticed that the image is flickering, but my camera is synced to 60 Hz at the moment, so it shouldn't. Okay, let's boot. No funny stripes on the screen either. Oh, now the Energy Star logo looks normal. Same thing with this splash screen. Looks perfectly normal. So did this card just need to wake up after a very long sleep? Okay, so Windows XP hanged again. So something isn't quite right. What is going on with this machine? Something is messed up. I hope this is just a software issue. I'll give it a moment and see what happens. No, the system is totally hanged. So I'm gonna have to reset. Well, maybe these cards just don't like to sit for 20 years without use. Because all the messed up graphics we had a moment ago, they are now gone. Everything looks normal. But something is messed up with Windows. So let's try safe mode again. I'm gonna cancel the installation here. Okay, I found the issue and it was not unexpected. So this machine had a Sound Blaster Live installed, and the chipset on these motherboards is known to have issues with the Sound Blaster Live. So I just removed the card and now the machine boots up. So I think 93.71 is the last known NVIDIA driver to work with Windows XP and the Ti4600. So let's install it. Oh crap, now I've got those stripes again. What is going on with this machine? Well, to check and make sure that this issue isn't caused by the motherboard, I installed the card in a tweener board. And at first it looks like it's behaving normally. We've got perfectly normal graphics here. And the card is installed. Now let's change the resolution. Let's go for 1024. Yeah, this is totally working. So do we have a compatibility issue with the VP6 and the Ti4600? Let's crank it up to 1280. Oh, now we got all the stripes back. So the card is faulty, but it works normally until you push it. Let's reboot the machine and check the splash screen. Yeah, there are some characters missing here. We've got the stripes here. Okay, so something on the card is marginal. Okay, I think I just got a lucky break here. And I think I found the original BIOS. So I'll format fresh diskettes and create an MS-DOS startup diskettes in XP. Okay, we're back at the Ti4200. Well, we don't have any graphics with this card at all, but I can hear very clearly that the diskette is loading the software. So we're not actually seeing anything on the screen. We can still load that BIOS with VGA BIOS. So I'm going to type VGA BIOS. And this file here is ET4200FF00.ROM. Here it goes. It's loading up the BIOS, but unfortunately the card still doesn't work. So unfortunately I think we have multiple faults. Either that or the BIOS I found just isn't the correct BIOS for this card. Oh crap. Next I grabbed the TL866 and I wrote the BIOS directly to the chip. Let's try again. Here goes. And unfortunately still nothing on the screen. So I'm pretty sure we have multiple faults on this card. Definitely a dead BIOS chip, but there is also something else wrong with this card. Well, needless to say, if you have one of these cards in working condition, then consider making a dump, because you may actually need it sooner than you think. And obviously, please send me a copy, or even better, upload it to the retro web. Now I'm going to start looking for RAM chips for these two cards. And when I have a few chips and the two BIOS files, we're gonna try to fix these cards again. And that is all I had for you guys today. A lot of work with very little progress, I'm afraid. But that's just the reality of messing around with vintage stuff. Sometimes you win, and sometimes you just have to try again. Before you leave, like and subscribe, and consider joining me on Patreon. Thank you for watching, and I'll see you guys again next week.